all. Today we're going to revisit piecewise functions. We did these before when we learned about lines, but now we have learned so many functions and we're going to incorporate those in this concept. So what I'd like you to remember is that a piecewise function is a piece of a function or many pieces of multiple functions. So in 1 through 7, I picked many different kinds of functions, basically one of every type that we've done, so you can see how you put it in the calculator, okay, on the specified domain. So here we go. I'm going to do number 1 on the calculator to show you. The others are already done, but I'll show you what they look like. Okay, so we put into x plus 3. That's nothing new there. And to put the domain next to it, you have to first click Control equals and this bar here. Okay, and the domain, this is a domain. Remember, this means x is between -1, including -1. That's what the bracket means, and 4, not including 4. That's what the parenthesis means. So x is bigger than -1 or equal to it, and less than 4. So the calculator doesn't take this notation. The only reason I put it here is that on the you need to know both notations. So I'm trying to cover both bases here. So in the calculator, you have to put this as an inequality, which is x greater than or equal to -1 and less than 4. So here we go, -1. Control equals has those inequality signs. X back to control equals and strictly less than 4, and then press enter. Why are you not? So I have to click this. Okay, press enter. Okay, book. So here we go. That's it. That's what it looks like. It's a piece of the graph. So we are going to take it. Those are the one. Okay. So we're just gonna grab it. I'll show you exactly how you would actually have to graph it on your paper to get credit for it. So let's put it on top here. And remember, when you draw your axes, you have to label them X and Y. Here they're already labeled in the calculator, but when you write it on your paper, if they're not labeled already, you have to label them yourself. Okay, label the graph. And since we know that, so here's -1, x equal to -1, and that's included, that means you have to make this point visibly big to show that x equal to -1 is a point in the domain. Whereas x equal to 4 on your graph is not a point in the domain, and you put an empty circle there to signify that. And that's it. That's all there is to it. Okay. So let's look at what the other graphs look like. Okay, that would be graph number 2. So let's see if I can get to that. I have to take this one off, and let's put on number 2. What is happening? 2. Okay. Well, you knew this was going to be a V-shaped function, and the vertex here is actually captured in this domain from 0 to 3. So notice you put that bar here after the function, you put that control equal and you go to the bar, but it turns into a comma when you press enter to graph it. So why the calculator does this, I do not know. Okay, so let's see what this would look like. And you should try this on your paper and then compare it to what I have here, okay? So my y-axis has to be labeled. The graph is labeled already. In this case, both the 0 and the 3 are part of the domain. So this graph starts at x equal to 0, and I have to put a filled in circle here and here to indicate that they're both included. That's it. That's number 2. And in case you have questions about absolute value, any funky notation can be found here. Okay. Okay. So let's go to number 3. That's a parabola. No you just need parentheses and a power there. Just in case you just got your calculator, I'll go over that. So the parentheses are here, and the squared is here. So you just click the x squared. It's going to give you that square. So this looks like, this is a parabola, so you should have some idea. Actually, remember 1 is subtracted from x. So do you remember what transformation that creates in the function? It moves the graph to the right 1. You might not be able to see this depending on what the domain captures here. So let's see what it captures. It does capture that. Because you could just see a piece that's up here so that you couldn't really see. I'm just going to move this over a bit. Okay, so once again, on your paper, the graph should look like this. But in addition to what the calculator gives you, you need to know to take care of the endpoints. So in number 3, when x is -2, the endpoint on the left, we have a hole because x is not equal to -2. But 3 is included. So at 3, we have a filled in circle. Okay. So we have the y, we have the x labeled, we have the function labeled, and voila, beautiful job. Okay. Number 4 is a square root function. So let's have a look at that. Okay. Here we go. And once again, this button has all the special, you don't have to press Control, just press this button and you'll get the square root in there. Okay, and that looks like this. Okay, so here's my function. Here. My x coordinate, my x-axis is labeled, but my y is not. I'm going to use this one for here. Function is labeled, and now let's take care of the endpoints. Oops, I don't think I captured the y. Maybe I should have captured everything, of course. Okay, so let's do this again. So that's what it should look like. That's better. It's more complete. You see the y-axis, you see the x-axis. A little bit of a glitch in the calculator, if you notice. When x is 5 here, y should be 0 because 5 minus 5 is 0 and square root of 0 is 0, so y should be 0, but it doesn't look as if it's touching, but it should be touching. So sometimes you need to fill in the math where the calculator fails. Okay, so there's a filled in point because there's a bracket, and the same thing at 9 here, x equal to 9. There is a filled in point. Okay. The next one is a cubic. And I think if you double tap on this, you can do that. And then number 5. So here, this is the cubic. Now, if you got this, you can move on, though I would just suggest you make sure that you know how to graph this yourself. So if you do a couple and you see that they jive with what I'm doing, you have the x and the y axes labeled, and you have the graph labeled, and you took care of the endpoints, then fine, just move on, but just make sure you know how to do it. Okay, so at -1 and 2, here, excuse me, here's -1 right here, and I have an empty circle, and when x is 2, at that endpoint, we have an empty circle because the parentheses. Okay, the parentheses translate into empty circles, and the brackets translate into filled in circles. And then number, well, that was number 5. So number 6 is a cube root. Number 6 looks like this. And there you have it. And it's pretty much really all you need to know about how to graph a function on restricted domain. Okay. So negative 5 comma 0. 1, 2, 3, 4, 5. Here's negative 5. So I have a filled in circle. And at 0, I also have a filled in circle because 0 is included. So now the last one, number 7, looks like this. It's an exponential. And think of how you're going to deal with the endpoints, and let's see if what you think is the right answer. So just for the last time here, x and y axes are labeled, the function is labeled, and your endpoints. Here the negative 2 is included, so I'm going to go ahead and draw a filled in circle, but 1 is not, so that's going to be an empty circle. Okay, that's that. So here what we have next is a system of 2 pieces. Okay, so this is what that's going to look like. So the calculator has an editor that does this. If you're familiar with Word, it's very similar to the Word equation editor. And this is what it looks like. So when you go to get this, to get the piecewise function notation, you go still to this button, and there it is. Okay, it's the 7th one over. And you double click and you just fill in the boxes, and there's no need for control equals. You just go there and put in for the bar to isolate the function from the domain because it's already built in. So this is what it looks like. So we're going to have a piece of this graph from -2 to 3, and we're going to have a piece of the parabola from 3 to 5. Okay. So there you go. And this is just a little bit more complicated, but not really. It's pretty simple. If you got what I did on the first slide, this is just a repetition of that, but we're doing 2 functions at once. So we have our x and y axes labeled already, and this first one here, from x equal to -2, here's -2, here's 3. So filled in and filled in because the brackets. Okay, these points are in our domain. Okay, and that's your line, piece of this line. Okay, then you have a piece of the parabola from 3 to 6. So at 3 for the parabola, we have an empty circle. Oh, don't mind my screwy circles. And at 6 here, 3, 4, 5. Actually, I guess this must have been a 5. Okay, it's going up to 5. There's filled in circle, and you're done. That's it, piecewise function. A piece of the line and a piece of the parabola. Okay. And then here in number 9, we have, once again, 2 pieces. This is a parabola because it's a quadratic, and this is a square root function. Let's see what this looks like. Okay, so really try this on your calculators, the TA Inspire. The old calculator really doesn't do this very nicely. So you have to do it by hand for the most part. But if you have the old calculator, just come see me. Okay. And here we go. So here we have a piece of a parabola and a piece of the square root function. Now the parabola is defined from -6 to 0. It includes -6. 1, 2, 3, 4, 5, 6. I must have changed this too. Okay, -10. Let's make this -10. So there's a filled in circle, but it's 0. It's an empty circle when x is 0 over here. The other function, so square root of x when x is 0. Huh. 1, 2, 3, 4, 5, 6, 7, 8, 9. 6, 7, 8, 9. So this is also filled in. And oh, this is actually 0. Let's not confuse that with so the origin x is 0, but here for the square root function, this is all filled in. Okay, both of these are filled in because they're both brackets. And this says 10, but it really is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think this 10 is for the end there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I think it's for the end somehow. And that's all there is to that. And we have one more. And that would be number 10. And number 10, I gave you 3 different pieces of 3 different functions. And that looks like that. Oh, and of course for this one, since you have 3 pieces, you have to pick this one, right? Because it's got 3 different pieces here. And that's what this looks like. Kind of cool. So notice as I'm moving it left and right, I can't really, there's no end to this one because x is greater, is less than -4, so it goes on forever to the left. And this other piece, x is bigger than 4, it goes on to the right forever. So you can make pretty designs and functions. It's pretty cool. And that's all there is to it.